Greetings to everyone who is watching my video. This is Kenneth from Makerere University. We have a problem here that we need to look at this time. So we are given a linear programming problem, and they are saying to convert the above linear programming problem into canonical minimization form. We are seeing that we have with the objective function is here. We have the constraints, but among the constraints, we have a constraint that is equal to. So this is our major interest. How do we deal with a constraint that is equal to when we are converting an LP problem into minimization or maximization? So I'm taking an example that if I have a constraint CXI equals to B for I equals to 1, 2, up to infinity, which means the same as having CXI greater than or equal to B, or it is the same as CXI less than or equal to B. So this is what we do for this equal sign here. So let me rewrite the problem. So we have minimize Z equals negative 2 x1 minus 3 x2 plus 4 x3 subjected to 4x1 plus 2 x2 minus x3 less or equal to 4. Here we have negative x1 plus 2x2 plus 3x3 greater than or equal to 6. Now this one here is going to be divided into 2 because it is an equal sign. We are following this principle here. So we shall have x1 plus x2 minus 3x3 greater than or equal to 3, or we shall also have x1 plus x2 minus 3x3 less than or equal to 3, x1 up to x3 greater than or equal to 0. So I have now made life simple. Having achieved that, we just need to now convert it into canonical minimization form as required. So the procedure now is very simple. Minimize Z equals to negative 2x1 minus 3x2 plus 4x3 subjected to. Since I'm converting it to a minimize, I need all the constraints to be greater than or equal to. So this one is less. What do I do? Multiply by negative. You'll have negative 4x1 minus 2x2 plus x3 is equal to is greater than or equal to negative 4. Equal to negative 4. This one is already greater, so I don't need to tamper with it. So I have negative 3x1 plus 2x2 plus 3x3 greater than or equal to 6. Even this one is also greater, so I don't want to tamper with it. So I have x1 plus x2 minus 3x3 greater than or equal to 3. This is less. I multiply by negative. So I have negative x1 minus x2 plus 3x3 greater than or equal to negative 3. x1 up to x3 greater than or equal to 0. In doing that, we have finished to convert our linear programming problem. In canonical minimization form. Don't forget to subscribe. Bye bye. Next time.